Hi everyone, it's Miss Spivey again. Today we are going to learn about electron configurations, how to set up our periodic table to do an electron configuration, and we're just going to get some practice in, okay? So to participate, you need your periodic table, you need something to write on it with, probably a highlighter or an ink pen, maybe different colors, and you also need your unit book. Go ahead and open up your unit book to page 8. Okay. So the first thing we're going to do, I just want you to blindly follow along as I'm putting numbers on the periodic table. We're going to put a 1 over here next to hydrogen, a 2 to lithium, so on and so forth as you go down the table. All right, then we're going to put a 4 down here next to lanthanum, a 5 next to actinum. Now we're going to do something a little weird. We're going to put a 3 next to scanadium, a 4, a 5, and a 6. Okay. Over here next to boron, we can still put a 3, 4, 5, 6, 7. Okay, so the next thing I want you to blindly follow and do is to write some letters on your periodic table. Okay. All of these blocks over here are S's, including hydrogen and little helium. Okay. Next, I want you to put a lowercase letter d here in the middle. Okay. Obviously, if you're being like me and you can't really read the letters very much anymore, I don't have a highlighter function. Oh well. So just write to where you can still see the names on your periodic table. I want you to write a lowercase letter p over here. And finally, a lowercase letter f all the way down here. And you might think that we're crazy and doing weird things, but this will make sense as we go along. So if you look at page 8, please, I want you to read the first paragraph. So go ahead and pause the video, read the first paragraph. It'll tell you about what electron configurations are. All right, so after reading the first paragraph on page 8, I think two big important things to pull away from the last sentences in particular are that there are two rules you have to know. Electrons hate each other because they're repulsive, right? If you put a bunch of negative charges near one another, they're going to repel. And they're also lazy, so that means that they're going to fill the lowest energy states first. Okay, so electrons repel and they're lazy. So if you look in the middle of page 8, it says electron configurations are nothing more than a detailed way to show the addition of electrons around the nucleus. Okay, so if you look at copper, we know that copper has 29 protons, so it's also going to have 29 electrons. Those 29 electrons are not all in the same place, and they don't all exist with the same energy. So an electron configuration is going to be a quick way for us to get more details about the electrons. Remember, we are interested in electrons because the valence electrons in particular take place in bonding. Okay, so in the middle of page 8, Aufbau's rule. A new element is created by adding a proton to the nucleus and an electron to the lowest energy level available. Highlight that rule, make sure you know it because it's extremely important for what we're doing. Now, before I actually show you, well, actually, let me flip over here. On my slide is an electron configuration for an atom, and I'm going to show you how to figure out what atom it is in a second. But a couple of very important definitions have to be reviewed first. First off is an energy level. Okay, an energy level is typically abbreviated with a cursive letter N. So anytime you see that, that's what we're talking about, energy level N. It is the big whole number. Okay, so this is an energy level. Here's an energy level, 2, 3. So just by looking at our electron configuration that you know nothing about, you should see that this is both the second energy level, big 2's in front, but then there's two different letters. What is that about? We'll get there. So another big thing to know is that not all the energy levels are in line. All right, so let me show you what I mean. Let me flip back to my periodic table. Here on energy level 2, lithium, beryllium, all the way across. Oh, sorry. I numbered these wrong, y'all. My bad. Don't judge me. So if you did notice, I casually fixed the numbers that I had written incorrectly on the right-hand side of the periodic table. If you numbered yours wrong, I'm really sorry. You can always get a new periodic table and renumber it. So I was talking about energy levels and how they don't go in the same line. So if you look at energy level 3, here it's on with sodium and magnesium. You come across, it's still energy level 3 here with from aluminum to argon, but it's also energy level 3 from scandium to zinc. Okay, look at energy level 5. It's here as well as over here, down here from Lu to mercury, Hg, also down here from Ac to No. So it's all still the 5th energy level. It's just not in a row, not all in the same line. Okay, sublevels are the letters S, P, D, and F. Okay, they technically tell us the shape of our electron cloud. S is a sphere, P is peanut, double peanut, and a flower shape. That gets more in depth once you go to like dual enrollment chem or AP chem. So on our sublevels, all sublevels hold electrons. Okay, so the sublevels are filled with electrons. So let's go through and count how many electrons fill up an S sublevel. So let's look back at the periodic table. Every single place where there's an S, 1, 2, 1, 2, 1, 2, 1, 2. So S's take 2 electrons. P's take 1, 2, 3, 4, 5, 6. D's take 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. F's take 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, so every number that I'm telling you can literally be counted on your periodic table. So S's have 2 electrons. P's have 6 electrons. D's have 10 electrons. F's have 14 electrons. Okay, S, P, D, F. So let's go back and let's look at this electron configuration here for aluminum. Oh, I just gave it away. I'm really sorry, y'all. I'm struggling on this lecture, so don't judge. Let me show you why this electron configuration is aluminum. Okay, so I come back to my periodic table. 1s, 1, 2. So that gets me the helium. 2s, 2, 2p, 1, 2, 3, 4, 5, 6. 3s, 2, 3p, 1. So that lands me here at aluminum at 3p1. Okay, let's see if let's look at bromine. And let's write the electron configuration for bromine. Okay, we're going to start all the way at the beginning. You can't bounce around. Okay, so for bromine, when we're writing it, we're going to start up here at 1s. And there are 1, 2, 1s boxes because we have to count hydrogen and helium. All right, next we come down to the end of our next line. So we're at 2s. So 2s2 over to 2p6 all the way across. I'm at the end of the line, so I restart. 3s2 over to 3p6. Again, I'm getting to bromine, and all I'm doing is counting. 1, 2, 3, 4, 5, 6. End of the line, I come to 4s. And now look at what happens. We're at energy level 3D. 3D, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 3D, 10. And 4P, 1, 2, 3, 4, 5. 4P5. So there's the complete electron configuration for bromine. Okay.